stage and buying some maple syrup and a hockey stick. Ladies and gentlemen, pack a thick coat in your luggage because we are going to Canada on Tuesday 7th of December at 4 p.m. Central European Time and 10 a.m. on a beautiful morning in Ontario and Quebec. And we are going there because at our epic discussions, we are seeing a major push in the microfabrication and testing for optoelectronic devices coming from North America, which could unveil major business opportunities for the rest of the members. So CMC Microsystems, EXFO, and the Canadian Foundry CPFC are opening their doors, inviting all of us in and preparing their answer to our epic question. We'll start at the brand new Foundry facilities for gallium arsenide, indium phosphide, and gallium nitride chips, the Canadian Photonics Fabrication Center, CPFC. And as usual, when we visit a foundry, we will ask them the questions that start business, such as what is the status of the PDK, which building blocks are standardized, how is the cooperation with the packaging and assembly houses, and the million-dollar question, how do you deal with wafer level testing? From their location in Ontario, we will cross the Ottawa River and enter Quebec, where we will visit CMC Microsystems. Moving up the value chain, we will understand the next stage in micro-manufacturing processes, optoelectronic chips prototyping, from design to packaging and assembly. And last but not least, we will visit a company that is enabling the testing of those chips at relevant environments, and especially in the datacom telecom sector, being the trusted partner of network operators and hyperscale data centers. I'm referring, of course, to the company EXFO. But what's their strategy for the testing of peaks with more and more added complexity? How do they plan to work with the wafer level testing equipment manufacturers or the foundries? So let's go visit the nicest people in the world. Our virtual networking plane from Europe to Canada lands on Tuesday 7th of December at exactly 4 p.m. Central European Time, 10 a.m. local time. And our colleagues from the local cluster OPTONIQUE will meet us at the airport. Register online for your free ticket to actively participate or watch the action through the window at our Epic Photonics YouTube channel. Ladies and gentlemen, we are live. We are landing from Europe to Canada. My name is Jose Pozo. I'm chairing this meeting from the company Heidelberg Instruments. In Heidelberg, they provide maskless lithography tools. And today I had the honor, the pleasure, the immense pleasure of organizing an event in which we are virtually visiting Canada. We're virtually visiting Canada because, I said in the video, we really want to find cooperation between the 759 members of EPIC and 3 iconic members that cover the entire supply chain from manufacturing to packaging and test. And we're going to start this meeting by visiting one of these iconic members. We're going to go to Ontario. We're going to understand the foundry services for indium phosphide, gallium arsenide, and gallium nitride manufactured by CNRC's Center, Canadian Photonics Fabrication Center, so-called CPFC. I had the honor and pleasure of going live and meeting Jelko Soloff from CNRC in Ontario. It's really cold today here. Is it so cold there as well?
Absolutely, even colder. Hello, and thank you so much for taking your valuable time to learn more about the Advanced Electronics and Photonics Research Center at the National Research Council of Canada. We are one of the 14 research centers of NRC, or CNRC in French, and we are actually the one research center that is focused on developing materials, devices, and optimizing processes for advanced semiconductors for applications in telecommunications, sensors, and many others. And we are also the home of the Canadian Photonic Fabrication Center, which is the only one pure play indium phosphide fab in North America. And before we actually go to the CPFC and tell you more about the facility and what we do and the type of business that we do and the clients that we work with, we would like to show you a few other exciting pieces of equipment and technologies that we work on. And the first one that I would like to stop by is our lab that works on advanced materials such as gallium antimonide, and you can see MBE equipment, molecular beam epitaxy equipment. And we build lasers in the mid-infrared, and we work with commercial partners actually to commercialize those technologies. And applications are very broad, but one of the most exciting applications in the greenhouse gas detection. And the next thing that I would like to show
Belko,
you.
sorry, you just showed us a gallium antimonide MBE reactor there. Can we use it? Can we get wafers, gallium antimonide wafers from you?
Well, we process gallium and antimonide wafers, and we actually work with partners to package those lasers and deploy these lasers in a variety of applications.
One of the biggest challenges of the EPIC network is that sometimes, especially for the gallium arsenide-based material, we don't really reach the volume demands for the big players to provide wafers. Can you provide wafers in a small volume?
Yes, we can.
This is interesting for the 750 companies behind me. Please continue, Belko.
Yes, so we are now in our advanced technology fabrication facility. This is one of our fabs that is focused on R&D projects. And you can see one of the bays, there are multiple bays down the corridor, but we just will show you one of them because of lack of time. And the projects that we're working here are our internal projects or projects with collaborators. And the focus on those projects is to develop technologies and devices on the pre-commercialization stage. So while we are close to the commercialization stage, we move these devices and these processes to our CPFC, Canadian Photonic Fabrication Center, where we can actually run larger number of wafers and volumes so we can support our clients in their new product introduction stage. One thing that I wanted to mention is in the last 25 years, we actually have been working also on organic semiconductors. And in the last decade, we have been having very big successes in the field of printable electronics. And you can see one of the equipments in our fab, which allows us to print variety of devices. And you can see here there's some detector arrays and some energy harvesting type of devices. Most of the applications that we're working on right now are in the field of sensing wearable devices. We can actually print on stretch type of textile and materials, which has a lot of exciting applications. And we're also able to work with a broad spectrum of partners in the printable electronics space. This group has been very successful in their commercialization efforts in the last few years. I would like to go next to my colleague Simon Winger, who is actually going to make you a tour to the Canadian Photonic Fabrication Facility. However, before we get to that step, we're going to show you a short video about CPFC. Thank you very much.
Jose, you can play the video.
The world relies on the light-based information that travels the global fiber optic network and its photonics components. The NRC's Canadian Photonics Fabrication Center helps bring your next photonics products to market. We work with you from the design phase through to commercial production to help you produce more, accelerate time to market, reduce R&D costs, leverage our custom services and unique expertise in design, fabrication, testing, qualification, and production to accelerate your time to market. Benefit from our tailored support at every stage of the process. Partner with us to achieve commercial success. The Canadian Photonics Fabrication Center. Light your future.
For me, it is really amazing to have one more foundry in EPIC. Whenever I go to visit a foundry, I get prepared to ask the right questions because I really want the companies in EPIC to find value in working with you and to help you solve your current challenges. You're doing a fantastic job. I had the honor and pleasure of now going to the clean room itself where the magic happens. Simon, thank you very much for having me here. I promise I will not touch anything. I learned my lesson. Tell us how we can help you in that amazing foundry.
Yeah, it's always a pleasure speaking to you. Okay, thank you. My name is Simon Wingar. Velko gave an excellent introduction. So I'm stood in front of one of the two wafer fabs we have here. As Velko mentioned, we have the Advanced Technology Facility, which you've just had a quick peek in. That's where we basically do the science and the technology. That's our NRC sandbox. And what's unique about NRC is the ability to take raw science, raw technology, and bring it through to the market, through to commercialization. So behind me, what we have here, I'm going to go through a few bays, is the Canadian Photonics Fabrication Center, which is about 12,000 square feet of class 100, class 1,000. And this is where we actually have that continuum all the way through from R&D, through into new product introduction, through into manufacturing, and through into actually sort of volume supply into tier 1, tier 2 type customers. So behind me here, we have one of our yellow rooms. This one that you can actually see here is our direct right E-beam system and our two eye-line steppers. This is our workhorse area for lithography. We're going to move down a bay now, and we're going to look into another part of our yellow room. And this is where a lot of our metrology takes place. So one of the key things, as everybody knows, if you measure it, you can ensure that you've got the quality. And quality is one of the key elements that we strive for here. So you see a lot of metrology in here. You see holographic benches for some of our laser work. And you also see some of the people. And what's actually very unique about the Canadian Photonics Fabrication Center is this mix of industrial engineers and scientists, so that when technology gets to the state where it comes to the CPFC, we've actually got the experience from companies like Nortel, JDSU in the past, and these people are now actually working for the benefit of all the companies that come here, not just one or two companies. And that's what makes it very, very exciting. The next thing I want to go on to is talking about some of the technologies. So as we go down and look into one of our white rooms, the technologies, as Velko mentioned, gallium arsenide, indium phosphide, gallium nitride, as well as gallium antimonide. And what's interesting there is you've got the tool set, which is a manufacturing tool set. And if you look at the gallium nitride process, both our gallium nitride 150 nanometer, as well as our 500 nanometer, we've got process design kits, which anybody can sign on to, and then it eases their design into our facility here. One of the interesting things is how we partner with our clients. So if you go back just maybe 10 years ago, the level of complexity that you saw into photonic integration were maybe 2 or 3 regrowths, 12 mask levels, maybe 200 or 300 process steps. That was the level of photonic integration we were seeing at that time. Fast forward to now, our clients are really pushing us to develop the technology and make sure it's manufacturable. So some of the latest devices that we actually have going to the facility here will have 5 regrowths, will have 25 mask levels, and 400 process steps. So that gives you just an idea of the level of integration and sophistication that takes place. Most importantly, for commercial application, is these processes yield. And so when we talk about yield, we're talking about numbers which will make it economically viable for a company to make a business out of the work. Now, the final part I want to talk about is what sort of companies work with us and how do we actually interact with them. But we'll go down to another bay first before we do that. So when we talk about companies working with us, we range right through from startups with just a handful of people into small, medium-sized enterprises, and some companies which will have their own fabs. They'll be fully equipped with their own wafer fabrication, but they don't necessarily have the development skills to actually bring that product to market. We also work with companies who will be fab light, as we call them. They'll have, say, the back end of the line, but they'll be missing those key ingredients. They don't have regrowth. They don't have the direct right EV. So we work right through the gamut from startups, through small, medium-sized enterprises, into fab light, and into multinationals who actually have the worldwide facilities. And we've been very successful in doing that. One of the key things that we have here, this is a closed shop. So it's basically just CPFC started here. So we're very conscious about protecting IP, our client's IP from a design perspective, as well as our own process know-how. And one of the key things is that we can build and continue to build that process know-how and apply it to our different clients' products. One of the ways we've found it being very successful is we just don't treat it as a black box. We actually form like a virtual group that consists of a company's designers, our engineers, their systems designers, and we actually work together as small teams to actually bring those products and those technologies to market. So that's just a real quick snapshot of what we do here. It's very exciting. And so what I'd like to do now is I'd like to hand over to Christophe P., our Director of Materials and Devices. We'll actually take you through some of the testing technologies that we have here.
And before we go to Christoph, Simon, at the end of the day, what we have here is not only a foundry, but also a center that is developing its own devices. You do have designers that are doing the design and they get the chips manufactured, but you also want to offer the foundry services to third parties, to companies outside to use the pure play services. For that, it's necessary to have a PDK, and that PDK to be understood and implemented by the software companies who are providing the solution. Talking, of course, Synopsys, Lucida, or the Canadian success story ANSYS. How does it work, Simon? Do you already have a PDK? Can the companies of EPIC implement a PDK already in their designs?
So we have a PDK for our gallium nitride. What we have is we have maybe 600 or 700 recipes that are inside our tools. So right now we don't actually have a whole PDK like say Smart Photonics might have, because we tend to find ourselves at the leading edge where our clients are always pushing the boundaries. So we're always interested in working with people who are very strong in their design. But we're also very interested in, as I say, working with some of those companies that you mentioned there about how to develop PDKs that lower the barrier to entry. So right now we have people who are very competent, who are very skilled, and live very high up in the integration level. But certainly, if we look at how we make it more efficient for people to come in at a lower level, technology level, then I think that's something I would be very interested in pursuing with your partners, your members.
Thank you very much. And I'm interested very much in helping you develop a PDK that should be open and flexible enough, because that's the biggest challenge you have from foundries. We need to be flexible because your customers want to be unique. And generic technology will sometimes not make them unique. Thank you very much, Simon. And let's go now to see the lab. I love seeing the lab. I will not touch anything, I promise. Johannes, thank you very much for being with us. Show us around and tell us how you deal with the biggest challenge in iterative photonics, testing.
Good morning, and thank you. Good morning to our European and Canadian friends. This is Christophe P. speaking. I am a Director of R&D at the Advanced Electronic and Photonic Research Center. And this morning, I will show you a little bit of our photonic device testing labs, where we make the proof of concept of a number of devices we work on at the R&D level and give feedback to our designers and fabs. And I will start by showing you a surface coupling station that is custom built and that can actually test devices on full wafers. It's automated and it's variable angle, and we can use it, for example, to test the quality of surface gratings that are designed with sub-wavelengths structures, and they can also, of course, be used to test PCMs on full wafers as a feedback to our fabs. I will now move to another station that was custom designed for our needs, and this is an edge coupler testing station, which is here. So as you can see here, it's able to test bars of devices, and here's a picture of the camera that allows the alignment of the fiber to the device, and we use it to test things like spot size converters and other low loss on broadband edge coupling devices. I will now move to a different type of device. It's actually a prototype of a sensor array. This is our so-called photonic wire sensing device, which is able to measure as many as 128 different analytes at a time on a silicon photonics technology with surface functionalization to be specific to a chemical of interest. And the chip is here, and you can see it's integrated in a full system that we designed to demonstrate the proof of principle, and we've used it, for example, to detect E. coli with very high precision. I will now move to two setups that are designed to test quantum dot laser technology, which we've developed over the last 2 decades. And I want to introduce Can Zeb, who's going to make the demonstration for you this morning. Good morning, Can.
Good morning. Hello, everyone. So
Good morning, Can. Every time, Can, just so you know, every time that we're going to see a live demo, I'm prepared for it not working, because live demos never work live. Please surprise me. Please surprise me. Let's make it work.
It's working now.
So NRC has been working on quantum dot gain material since 1994. In recent years, we have developed successfully some different types of quantum dot multi-wavelength laser for terabit networks, such as data center, 5G and beyond wireless networks, and satellite communication. Here is an example. I will show you 2 different types of quantum dot multi-wavelength devices. On this testing station, we have a quantum dot multi-wavelength coherent COM laser, and with the free spectral range of 34 gigahertz. And here we can see on the OSA its optical spectrum. These lasers can achieve a relative intensity noise, like integrated relative intensity noise for each individual channel less than minus 130 dB per hertz. And here we can see a typical range spectrum for this device. Now, if you move on to the other side, we have this testing station where we have a quantum dot dual wavelength DFB laser. And these lasers are very low noise and high performance laser that can be used to generate spectrally pure millimeter wave signals. And here on this electrical spectrum analyzer, we can see its RF beat note signal at 47 gigahertz. Now we will move on to our.
So what we saw there is the beating of the 2 modes in the photodiode, right?
Yes.
I only saw the beating of the 2 modes, because the cameraman was really too fast. I couldn't see the frequency. So what you're saying there is that we can actually have dual wavelength quantum dots. You have proved that, but is that something that we can access? Can I get the companies behind me to access that technology somehow? Because we do want to have more quantum dot based manufacturing for our devices in Europe. We don't have much.
So maybe I can handle that question. At the moment, we don't have a commercial offering of quantum dot lasers. It's still at the experimental level. We have lots of collaborators, and we're very happy to entertain other collaborations. And we're working towards developing a commercial level process for our quantum dot lasers.
We are talking 1.3, 1.25 micrometers wavelength, correct?
It's 1800 micrometer, this one.
Okay.
This specifically, it's basically has a specialized synthesized grating, so with which we can generate like multi-wavelength different modes. So for this particular laser, we have a dual wavelength, and this was specially designed for 5G millimeter wave signal generation.
We love the success story of Inolium. We want to have more success stories in EPIC like that one. So here is the challenge. All the EPIC members, they are looking for partners to develop the quantum dot manufacturing line for 1.25, 1.3 micrometers. Thank you so much. Please continue.
Okay, so now we will move on to our system experimental setup, where we perform different millimeter wave radio or fiber experiment for 5G radios using our quantum dot multi-wavelength laser technology. So basically, the laser that I'm just going to use over there. So we take the light from there. So basically, I'm going to show you a real-time demo of a broadband photonic millimeter or fiber wireless link with a data rate of 16 gigabits per second using our quantum dot multi-wavelength laser. So we take the light from there, split it into 2 parts, and one of the wavelength of the laser we modulate with the baseband 4 gigabaud 16 clock signals, and we take another wavelength that we use as an optical local oscillator for remote up conversion to a millimeter wave signal. After transferring these 2 optical signals to a 25 kilometer standard signal mode fiber right there through that spool, And then we receive this optical signal right here. We can see this is an optical local oscillator, and this is our data channel. We basically beat these two signals together on a high-speed photo detector directly attached to a horn antenna to a power amplifier to generate millimeter wave carrier at 47 gigahertz with 4 gigabaud data. And then we transmit this signal over 2 meter p-space length, and then this is received by another identical horn antenna. And the signal is down converted to intermediate frequency before capturing and analyzing into a real-time oscilloscope for demodulation. So here we can see a real, if you go a little bit that side, and we can see this is a real-time demonstration. So for example, if I block the millimeter wave signal, you see nothing. If I tap, then we have like a pure, on this screen, we can see a constellation diagram, eye diagram, RF spectrum of the demodulated wirelessly received 16-pump signal that is been coming through the 25 kilometer standard single mode fiber, and then over 2 meter wireless distance using our quantum dot multi-wavelength laser. So this shows that by using our developed quantum dot multi-wavelength laser can facilitate seamless fiber wireless integration, which is necessary for 5G and beyond wireless networks, because this not only overcomes the problem of high bandwidth requirements, transmission capacity, and spin limitation of these high millimeter wave frequency signals, but at the same time, this can significantly reduce the cost and complexity, especially in the case of 5G. Small cell where a large number of remote radiohead will be deployed. So if somebody is interested, so these basically, if you look again to the constellation, so each constellation basically point to represent a symbol, and each symbol contains 4 bits. And we have demonstrated successfully such links over longer distances with up to 50 gigabits per second data rates using our quantum dot multi-wavelength laser. Thank you.
Thank you very much, Joel. It works. It works. It never rarely works. It works. So, of course, you didn't give us measurement of the bit error rate, but I will let you off the hook. Thank you very much for that demonstrator. We have lots of work and lots of questions in the room. I understand now we have a few minutes now for a Q&A, right, Johannes?
Thank you. And you see, nothing went wrong. So I'm going to go back to our Director General, Veljko Tsolov.
Well,
thank you very much, Veljko. It was truly fantastic to be here. I have a lot of people who want to ask questions, but most important, who want to collaborate with the Foundry that you are setting up. The first question comes all the way from Eindhoven. I call it Eindhoven Rock City. We go to PITC, the Packaging Center of Excellence that is being set in the area of Photon Delta. PITC is represented today by their director, Jan Lorenz van der Stern. Jan Lorenz, thank you very much for being with us. You already cooperate with Smart Photonics and other foundries. How can you help NRC doing even greater than they already do?
Yeah, so first of all, thanks for giving me the floor. It's very nice also to have, you know, to be able to look into your labs right now. It's very nice. It goes all very fast, but it gives a very nice overview. I have indeed a question about the Foundry. So just a very brief intro. I'm with Photonic Integration Technology Center. And one of the things that we do is running shared research programs, and one in particular is, for example, on the core technologies, what I call indium phosphide, as Jose pointed out with SMART, for example. So I was wondering, let's say the early stage technology. So you pointed out that you actually work along quite a, let's say, broad range, also doing the so offering the services and also doing technology development for companies. So how do you see, let's say, the development of, let's say, these general building blocks that, let's say, are needed for multiple applications? How do you typically do that type of technology development?
Okay, Veljko, do you like me to take that? Yeah, he's on mute. I'll take it. Hi, it's Simon here. Traditionally, we've actually worked very, very closely. So one of the benefits of actually being in Ottawa is the legacy of Nortel and all the small companies that spun up from that. So we actually get together one-on-one. We have a room in the basement where basically every day of the week, those teams get together. And we're actually co-developing almost like individual companies' own PDKs in that sense. So they get access. So there's a lot of data just shared. So a lot of process information and data is shared, and it allows companies to basically build their own differentiation. So that knowledge which separates their devices and their product development stream from everybody else. But what we don't have is, like you guys in Europe, which I'm really envious of, is this broader platform that actually stimulates growth of new companies that actually don't have those skills. And so I'd be very interested to actually sort of share and learn the best parts of both methodologies. And maybe we can help you guys out with how do you actually take the really advanced stuff and move it forwards and work in those collaborative teams. And we can learn from you, how do you actually build those real basic blocks and say, okay, there's a whole, we focus very much on very advanced telecom type applications. But as we're seeing, the world's getting broader and broader. And one of those things that actually take people who are traditionally not compound semiconductor specialists and actually get them into the field and stimulate that kind of growth. So it'd be very interesting to talk to you guys.
We're both jealous on both sides, Simon, because I'm very jealous because we don't have a photonic gallium nitride foundry offering pure play services in Europe. We don't, and we have one epic thanks to CPFC, thanks to NRC. Thank you very much for that, Simon. This wouldn't be a 3-5 meeting without the next person that is going to ask you a question. I had the honor and pleasure of giving the floor to Valery Tushin, CEO of Intengent and one of the epic figures in the 3-5 compounds. Valery, thank you very much for being with us. Speak your mind.
Good morning, Jose. Very great to see you here, and I hope you are in Montreal, not in Hague. So welcome to Canada.
Thank you.
I know very well what is CPFC, having a luxury being next door to it, and some older guys at CPFC, I still hope remember me. Nevertheless, I have a question to Simon. Hi, Simon. Regarding the business model you described to us some time ago. So you said that a specific feature of the CPFC as a foundry is a deep collaboration between the fab and the design team in developing something new. Suppose this happened. Suppose your team, which hire you to do some work in indium phosphide, has developed a very nice integrated laser plus, say, Mach sender. And it works. Now what? You have another customer who comes in and wants the same. How do you go around that? There is IP barrier on one hand, on another, would you do this from scratch the same with another team, which is very difficult to conceive? How does it work?
Maybe Valery, it's Velko. Maybe I can take this question. Very nice to see you. I would like to say that even today in our fab, we have very strict measures to fence the IP of the clients we work with. So even today, when we run the wafers, we actually have probably 3 or 4 clients that are in competitive position, if you look at that. So there are measures at place that actually fence the intellectual property. So from that perspective, most of the projects that we run are actually qualified as projects in pure play foundry. So we don't own the IP. We don't pretend that we own the IP on the device and the design side. What we do is we develop and own intellectual property on the processing side. So this is where
So that's to answer my question. If somebody asks essentially the same as a building block of a distinct peak, you will do a brand new development with this new customer as it would be from scratch. Is it right?
Well, if the client comes with a design, they own in the intellectual property, and the client wants to actually work with us so we can optimize the processing side, that's the type of scenario that we will entertain.
Thank you very much, Valery, for being with us. Stay with us because now we are going to go from the foundry to the testing equipment. We have managed to make the chips. Now let's get them tested. And for that, we go to Quebec. And we go to Quebec to visit one of the epic success stories, the company EXFO. Thank you very much for welcoming me in this beautiful, beautiful country, in this beautiful region with this amazing food and people. I want to meet my friend Gwen Amis from EXFO. Thank you very much for being with us. Thank you for having me with you. tell us how we can help you be even greater than you already are.
Hey, Jose, how are you?
Doing fantastic. When I see you, I do even greater. And when I see you smiling like this, oh, I wish I could be there with you. I really wish I could be there with you.
You know, when it's -7 outside and freezing rain, you have to smile. That's the thing.
And once you smile, it stays like this the whole time, and you're smiling also.
Absolutely. Absolutely. So yeah, welcome to EXFO. We're in Quebec City here. We've prepared, in fact, we're bold because we've prepared three demonstrations today. Oh my God, it's so far so good, huh? We prepared 3 presentations for you today, 3 demonstrations. In fact, I'm going to go through this quickly, but we have 3 product line managers that are going to show, in fact, different products in a few minutes. So we're going to go in Lannion. So we're in Quebec City, then we're going to travel the ocean on the other side. We're going to go to Lannion in Brittany, France. And then we were going to come back here and we're going to have another demonstration of, you know, the different products that we're offering. So as you know, EXFO, we are specialized in test equipment. So every customer is different. Every test solution is different. So working with EPIC, with OPTONIQUE it's really great because we can network, we can talk to the users directly, and we can develop solutions. That's key, in fact, in our line of work, because there is not one solution that fit all, in fact, especially when we go into the peak market. You know, the wavelength range might be different, or the dynamic, or some specific parameters will be different. So long story short, EXFO, 35 years old. We are in the birthplace, in fact, in Quebec City here of EXFO, headquarters as well. We are about 2,000 employees all over the globe, in more than 25 countries, in fact. R&D centers in Lannion, for instance. We have, of course, a big office in Montreal as well. And in Taiwan, latest acquisition, in fact, was in 2020. So that's pretty much it for EXFO. And the way you can help us, well, it's easy. We're going to help each other, either working with the foundries, working with wafer handlers, working with PIC manufacturers in general, or even components. I mean, we can work at the PIC level, but we can work obviously at the component level, or integrated component level. As you know, EXFO is really well known in the industry for test equipment, not just in the manufacturing domain, but also in the tests like 5G deployment and system vendors and fiber to the home. Anything that has photons involved, we are involved.
I have used your testing instrumentation. I'm a big fan. So together, I just arrived in Canada, and together we go now to the northwest of France. We go to the region of Brittany. It's beautiful this time of the year. We go to Lannion, unless Johannes is pointing the finger up.
Yes, absolutely. Before going to Lannion, in fact, I just want to show briefly one product.
Please.
Yes. So Guillaume is going to show you, in fact, one of the latest products we have, which is, in fact, a fiber inspection probe, if you don't mind.
Of course, I never mind, especially about this. I'm extremely interested.
All right, hello. Thank you, everyone. My name is Guillaume, and like my colleague Gwen said, we have a wide variety of products. We covered field application, lab application, and one of the key solution that we launched last year that is really popular is this FIP 500. We wanted to explain it in a bit more detail because it's really applicable for any photonic integrated circuit or any application, in fact, that includes fiber optic connectors. I'm saying that because fiber optic connectors, really the connector and the cleanliness, the state of the interface is one of the main problems that we see with any type of application, including fiber optics, even more when you have high speed running on those. So a small connector like this, you would have 12 fibers on this one. There are other variants with more fibers, 24, up to 4 rows of 12 fibers or 4 rows of 16 fiber. So a lot of fibers in a really small footprint. So a fiber inspection scope is a specialized microscope that is going to take an image of the connector interface and look at all those fibers and will identify if there are any defects, any scratches, any dust or particle on the connector interface. And this is really specialized because we're going to look at defects that are as small as 2 micrometers. So we need to find them, locate them, analyze it, and give a pass-fail status on those. So portable tool that can be used in the field, in a lab equipment. There are different connector types. I've shown one, there are other ones. So you have interchangeable heads like this that you can change to accommodate the different form factors of the connectors. It's a tool that has its screen. So you see what it looks like. This is a connector image that I have here. So it gives you the status. You have a LED in the front of the tool that would turn red or green. And we really want to make those units easy to use, intuitive, automated, so that anyone, no matter what's the level of technical knowledge you have about this, you feel confident using those equipment to test your fiber optic connectors.
Red or green light. Red or green light. That means that when you plug in the fiber, you are observing the core to see if it's dirty or not. Does it show a red light when it's dirty? Does it actually make some kind of intelligent imaging of the core?
Yes, yes, exactly. It's going to take an image of the cord. It's going to give you the image like we have here. It's going to put a red or green, an overlay. And this LED here in front would be red or green to tell you if it's good or bad. So really, it looks at the defects. It measures them, locate them, and apply the pass-fail threshold. So we go with the IEC standard, which is the industry standard for fiber optic testing. And it applies those pass-fail on the image to give you the status of your connector. So even if you're not necessarily familiar between what is good, what is bad, the tool will tell it for you. So really automated and easy to use in that fashion. Yes. So this is one of the units we wanted to show, but we have a lot of other units. In fact, we have products more linked to PIC applications. I'm gonna now pass it over to my colleague François, who's based in Lannion in France, where we have our R&D center for all those products here.
And now, yes, we go to the northwest of France. We go to Brittany. We go to Lannion, next to the beach in a beautiful part of the world. François, bonsoir. Great to see you again. The floor is yours. We may have a sound problem to hear François. We cannot hear François, which is a pity because I really would like to hear
it's
that.
Okay. Yeah, I think you can hear me now.
Yes, now it's okay.
Yeah, very good. Well, welcome to EXFO Optics, which is indeed based in France, in Brittany. So we go from the snow to the rain. Actually, it's raining quite badly today and right now, so it's great. So EXFO Optics is concentrating on manufacturing, design, and research instruments for testing of mostly spectral applications. So optical spectrum acquisition is what we do. EXFO Optics used to be Yenista, used to be about 40 people, and it was acquired by EXFO in 2017 to expand into that particular market of manufacturing and testing for R&D. Recently, we also acquired Inopticals in the same way. So Inopticals is a Taiwanese company, and it's a smaller entity, about 50 people, and they're concentrating on eye diagram and bit array testing. We'll hear a little bit about that a little bit later on. So if you come this way, we'll move into here in front of the lab that we call the application lab. This is basically where we use our instruments, such as the CTP10 here, for applications that require some testing, and the customers have particular questions, or we require to create an application note or a white paper, and we would take these instruments, some of the third-party instruments, and put it together to try and demonstrate the facility, the capability of the instruments. This is key for any applications, particularly for PIC, so photonic integrated circuits. We have been developing over the past 10 years or so dedicated instruments where speed is of the essence. The CTP10 is one, and the OSA20, which is the optical spectrum analyzer, is another one. And we have actually seen earlier some pictures of our products being used, namely the optical filters, XTM. So here in the lab, we have two sets of demonstrations. So we doubled the antes here. It's not one demo that needs to go right, it's two. So fingers crossed. So the first one is with the CTP10. So the CTP10 here is an instrument that takes care of measuring insertion loss, return loss, and polarization dependent loss on a device. The device can be, in this case, a very small LAN WDM MUX, but it can also be a PIC. The difference is that instead of being directly coupled with fiber here, you would couple it with a fiber array in and out, for example. So the CTP10 operates with a tunable laser source to obtain the spectrum of the device. So the spectrum is the power going through the device as a function of the frequency or the wavelength. So here we can see for 4 channels, the particular filtering functionalities of each of the channels for the LAN WDM. So that's 4 traces obtained with a 1 picometer resolution, thanks to the system that we call that is called a swept wavelength technique. Here you will also notice that the dynamic range here is obtained with 1 single sweep. That's because we don't have any gain or ranging into our detectors, and so we only require one sweep to achieve the full dynamic range of, here we have about 75 dB of dynamic range. And the second part also is that we have the hang on, something is ringing. Can you still hear me?
Yes, loud and clear.
Okay.
Like you were next to me.
Okay. And the other thing, if you can try and zoom in, is also the repeatability. So here, this is a live view, and we have the analysis here, is live analysis of the channel. And in terms of reproducibility or repeatability of the wavelength, here we can see that it's not moving at all in terms of the number of analysis, which means that the system is reproducible or repeatable to within a 0.1 dB or so. 0.1 picometer on the analysis part. So this is more for analyzing passive components, so things that do not emit light, such as WDM systems or MUX, or indeed ring resonators when we talk about PIC. But what we do when we want to test active components, such as lasers or amplifiers, then we would use an optical spectrum analyzer. And here, once again, speed is of the essence. We have designed the OSA20, which can scan up to 2,000 nanometers per second. So it is very fast indeed for alignment purposes. For example, here we can see a tunable laser that's actually performing a sweep continuously here, and we can see the line moving, taking 4 or 5 measurements per second. So that's very fast. Also, we, at the same time, have an analysis going on, so we can have an idea of the OSNR or the SMSR, the gain or the noise figure when we talk about amplifiers. So all these instruments here have been really designed for PIC application, where the speed is of the essence and the accuracy, repeatability is required. So I don't know if you have any questions regarding.
Yes, we do, because Francois, you know what? This event is global. So we went to Canada, and we go from Canada to Brittany, and now we're going to go to Peru in South America. Actually, one of your customers is in the room, and he has some ideas. He's very happy with your technology. He actually used your technology before, but he wants to know about the next generation OTDR. Thank you very much for being with us today, Ronald Meza from the University Nacional of San Agustin in Peru. Ronald, can we hear you? We may have some audio connectivity problems, but this is what he's wondering about. He would like to, let me see, can we hear you, Ronald?
I can, you listen me?
Yes, we can hear you loud and clear.
Well, I'm seeing the a OSA equipment, and my question is, what is the newest product of EXFO about OSA?
So in terms of OSA, we do have the OSA 20, which is the I would say the top range in terms of R&D work with an analysis, for example, that has many settings. If you want a more automated OSA or something that is more compact than the OSA 20, then you could also go for EXFO's OSA, which are modular, and I hope that we will see them in the next section of this presentation. But in terms of OSA, we have released the OSA 20. We have some software updates, but also on the EXFO's OSA, we've had an OSA, namely the 5243, which has an integrated gas cell inside for improved accuracy in terms of wavelengths.
Fantastic. Actually, both Ronald and I are big fans, not only of the hardware, but also of the software that comes with the OSA. On that, we both used it for our experiments in the past. Francois, it was really great to be there with you. I really hope I could be there in person. I could go for fantastic dinner. They have great scallops in Lannion, by the way, if anybody goes there to visit. Shall we go back to Canada?
Yes, I think we should. And join Louis.
Let's go back to Louis Forget. Louis, thank you very much for being with us. We see a fantastic rack with fibers hanging. That's what I expect when I go to see an EXFO location. Tell us how we can help you.
Sorry, can you repeat the question?
No, in general, what do you do and how can we help you do it even greater than you already do?
Thank you. Well, this is actually the kind of stuff that you could see in test manufacturing environment. Today, I'm located in the heart of the location where we have our remote demos, meaning that if you as a customer want to have an example or an explanation of how our equipment are working, how the applications are made out, and you have the ability to do that using the remote setups. Because in our new virtual world and everybody's stranded on their location, it's a good advantage to be able to see the equipment differently. So in fact, we have the three main types or three main BUs or business units or categories of products that we have at EXFO. The first one being the MDR portion, which stands for Manufacturing, Design, and Research. These are the equipment that are addressing the application that are more for the labs and specifically in manufacturing. Those units are usually rack mounted. As my colleagues pointed out, we have the in-opticals products here that are benchtops as well. And those are all modular equipment most of the time. You have the LTB8, LTB12, and all the FTBX format, which are all integrated inside our mainframes. So this is for the MDR market. The other segment that we address is the field applications, where we have ruggedized devices that address technicians who are installing new fibers, new test equipment, new telecommunication instrumentation that are in the field. So we have, again, ruggedized equipment that are able to monitor, or not to monitor, to measure how the light is traveling through a fiber and make tests along great distances using the OTDR, which is by far one of the greatest products that EXFO sold for many years over the length of the 35 years that we've been in business. So again, you have FTB2, FTB1, LTB1, which are, again, devices that are addressing the field installation and debugging of the network. But once you have, if you go back, if you move up the chain, you have the lab and research group, and then you manufacture the test equipment. Then you install it on the field, and then you want to monitor what's going on your network. So the third group of products that we have are the monitoring devices, which are mainly the Fiber Guardian and the NQMS products family line. And we also have another big unit in Lannion, not Lannion, but in Rennes, France, again. and they have the SaaS business, which is monitoring and is providing very advanced solution for making sure that your network is working fine. And whenever there's an issue or there's a problem, our systems are able to find the issues very fast and provide some help into solving this. So monitoring business is definitely another key factors for where EXFO shines in terms of product solutions. So again, for the manufacturing, any types of application that we'll be using if we're looking more at the PIC type of marketing, Francois just told a little bit earlier about the OSA 20. If we move back a little further down here, we have the OSA 20, which is available as a remote setup. So if you talk with one of our regional sales manager or distributors, you will be able to see a demo of this application, and it's also a great way to do some training. So if you have either a question about the product, or if you already have this device but you're not sure how it operates, or you want to have more information about it, then you can ask for training on those specific devices. So that's basically it. I know on the modular side of things, we also have key building blocks like power meters, attenuators, switching. We also have spectral analysis tools, just like not all, like the OSA 20, which is highly advanced for the PIC market, but using those key components, you would be able to address transceiver testing applications.
Louis, today I am connecting from a company called Heidelberg Instruments, and they took me around the facilities. I was impressed, and I told them, look, you are normally welcoming your customers and train them how to use the machines, but now we have a pandemic and it's very difficult to travel. So they say, no problem, because we are doing our training sessions and online. So the users are actually following how to use the machine online. EXFO has been quite good at training the people how to use the equipment. Was the pandemic an opportunity to train the people online? Are there training ways of getting training on using the testing equipment without traveling these days?
Yeah, definitely. We have online training. Usually, there's some limitation at a point where online training is enough or is sufficient. Especially if you install fiber in a very specific environment, it might become difficult to do that all online. But with YouTube and all the videos that we have, sessions like today, we definitely have a lot of input and additional information you can gather with the videos, so that at least you get a first draft, and then putting all the hands on is definitely something that is better. But with the pandemic, we had to adapt just like everybody else.
What I can tell you these days, Johan, Louis, I can tell you, Francois, that the pandemic has made the photonic companies excel, go outside, talk more, network more, and thus we have grown, and find ways to cooperate. I want to find you a cooperation today. I have the honor and pleasure to welcome into the room one of our biggest success in the European industry in photonics, Excelitas Technology. Matthew, thank you very much for being with us today. Thank you for joining me in this visit to Canada and Lannion. Matthew Postner, how can you help or how can you collaborate? Excelitas and EXFO.
Thanks, Jose, for the introduction. And although I may sound European, I'm actually speaking from Canadian soil in Montreal today. So yeah, I'm just wondering, on the other side, how do you at EXFO integrate components into your systems? And I think coming from a sort of component supplier perspective, do you buy from component suppliers or collaborate to reach new markets? And what may they be? I'd love to hear your comments and views on that.
Well, it all depends on the type of components. Of course, we integrate a lot of optical components inside our devices. And when it comes to very highly specialized and highly complicated systems, we might go into more like a collaboration and eventually work on as much as possible when there's commercial viability. We try to we definitely cooperate to bring that to market and make this as a win-win situation.
just to maybe specify specifically on sensors, collaboration and those aspects of photodetectors, APDs and pins, which is where my vested interests are.
APD is definitely something that we need to actually collaborate a lot, because it's the foundation of the OTDR market, one of the key components of our OTDR. So it's not only cooperation. We usually work upfront with the design and the definition of what the product is supposed to be doing, or what the component is supposed to be doing. So yeah, definitely we are cooperating at all levels, not only with the hardware definition, but also the software and automation portion. I know many of my colleagues are involved in system design and system integration with customers and suppliers as well.
An amazing success. You are collaborating also with the machine makers doing the wafer level testing, doing dynamic test on wafer. With the burning test machines, you are collaborating with the people doing the quantum research. Hey, the people doing the quantum research, Louis, Johannes, how is the quantum business going? Because I noticed that this is a buoyant thing, and I see the EXFO logo every time there is a quantum event. How do you see quantum as an opportunity?
Well, just as the gentleman from Excelita said, we could eventually integrate some quantum dot lasers inside our equipment. But again, this is, as the National Research Center said, it's not at the business stage yet. So whenever we have, and we're collaborating to bring those components up to the market inside our test equipment.
You know what? You know, when I go to Canada, I talk about quantum. The reason for that is because one of our quantum experts is in Canada. You are talking, of course, about Quantum Valley Ideas Lab, Nick Verstout in Waterloo, Canada. Nick, I went to Canada. I'm talking quantum. What do you see here as a resonance? What do you see here as a potential cooperation between Quantum Valley and EXFO, or the other manufacturers and packagers that we're going to meet today?
So one of the areas that we're sort of focused on, so just to kind of place us, right? So we're a not-for-profit advanced technology research lab around Waterloo. And so we've been working on a set of quantum sensing opportunities, actually Rydberg atom-based for RF sensing. So obviously that has a typically vapor cell excited by a laser, probed by a laser, and then read out optically to kind of generate measurement of RF fields. So that's kind of our core set of projects. And one area that's interesting, right? And I think the NRC talk was also interesting in that sense, right? Is, you know, this continued desire to reduce swap of the whole system, right? And so the opportunity for you know, to push the lasers toward PIC-based lasers and sort of packaging and things like that is kind of where our thinking is, right? So that's a big area of, you know, future interest, right? It's not something we're doing today, but it's an area of future interest that we're sort of interested in exploring as we move forward.
Louis, Johannes, Francois, Nick, thank you very much. You guys, I have a big problem right now. I'm in EXFO and I need to get to CMC. I have no idea how to get there. Can anyone help me?
Jose?
Yeah.
How about I help you get all the way over back to Canada to visit CMC Microsystems? What do you say about that?
Please, let's drive together. Who are you? How we met?
So hi, everybody. I'm Madison. I am the interim general manager of OPTONIQUE, and OPTONIQUE is Quebec's Photonics cluster. So Quebec is more part of the eastern side of Canada. It's kind of cold in Quebec, but there's a lot of great companies and a lot of great people with great expertise in photonics. And it's my pleasure to help introduce CMC Microsystems. So like Jose introduced, when you mix a love of maple syrup with very nice people and expertise in microsystems and nanotechnologies and photonics, you get a nonprofit organization called CMC Microsystems. So they are there to help researchers, help industry across Canada develop innovations. And it's my pleasure with Jose to introduce Gordon Harling, the CEO of CMC Microsystems.
His friends, we call him Gord. Gord, oh my God, it's so great to see you here. Thank you so much for being with us. I really wish I could be there with you right now. I really wish I could be there with you.
It has been a long time.
Yes.
But we're not going to be as impressive as some of the other presenters because we don't have bricks and mortar. We're really a virtual entity. And in fact, it's hard to visit us because we span 3 time zones and 5,000 kilometers in distance. So I'll just talk a bit about what we offer in terms of a virtual entity, and I am sorry if I have to revert to PowerPoint. There we go. Whoops.
Let me
Move you
see,
a bit.
the image
There we
is
are.
not yet here. We still
How's
cannot see
that?
them. Now it's perfect, the way that you deserve.
Good. Okay. So the way I deserve. So we again are a not-for-profit, much like you, Nick, and we were founded in 1984, and we manage a major science initiative called Canada's National Design Network. So we support microelectronics, photonics, MEMS, nanofab, AI and machine learning, and as of about a year and a half ago, quantum technology. To the extent that we offer, we purchased a share in the first IBM Quantum Hub in Canada. And so we offer coding assistance. We have 2 coders in Sherbrooke, Quebec, and we have 2 others in our photonics group who are cross training. We're currently running, we've run 15 projects in quantum coding. 4 of them have completed and papers published, and 11 more are ongoing, and they cover everything from civil engineering to med tech to some of the weirdest things I've ever heard of. But we help people. We take their code, we verify it, we run it on the largest IBM machines, and then we help them to interpret the crazy results that come out of that. We are agnostic as to strategic sector. We really don't care what you use our tools for. It could be absolutely anything. We have lots and lots of success stories about people who've built on our tool set. And again, we're all across Canada. So in 2021, these are the results reported by our users: 4,000 publications, 80 patents, 14 new startups, and 610 HQP moved to Canadian industry. Another 100 or so went into academia or into institutes like the NRC, and about another 200 went to their home countries. But considering that out of the 1,000 people who used our tools, only about 200 of them left, we're getting a brain gain by people staying here after they finish their studies. So it's good news for us. And what we offer is CAD, Fab, and Lab. So the CAD is, we purchase bulk licenses from about 30 different vendors. We float them in the cloud, so anybody can open a browser, open their CMC account if they're a subscriber to our service, and use the CAD. And that includes Cadence, Mentor, Synopsys, Photon Design, Lumerical, everything you've ever heard of. On Fab, we run about 50 Fab runs a year. We're expecting to do about 380 chips this year, over 120 in photonics alone. This year, we're having a really banner year, and silicon photonics is really exploding. And for Lab, we actually build platform technologies. So we try to build something that researchers can use to work on top of, so it saves them the effort. So we do have a photonics toolkit device, which has got 3 Mach Zenders, some ring modulators, ring resonators, some modulators, and so on. And Dan Deptok, who's the head of our photonics team, will talk about that a bit. But it's all about speeding up research and getting rid of the grunt work, the stuff that's not paper worthy. We operate a worldwide industrial chain, a supply chain with CAD vendors and fab suppliers all over the world. And we do a lot of work with folks in other countries. Right now, we have a 2-year program to develop a RISC-V processor core, which will be available as open source, and we're doing that with ETH Zurich. So you can do edge processing for IoT devices and that sort of thing. Lots of do take a look at our website and look at the resources there. We're a member of many societies, including EPIC there on the left, and so and we're very keen to come back to Europe and start doing your events. But we try to stay on top of all of the technology areas that we serve, so it keeps us busy. And we actually had just yesterday a meeting with all our peer organizations across the world, Korea, Japan, Taiwan, Europe, Europractice, and so on. And so we discussed what new services we have and what our funding difficulties are and how we can help each other. So we do try to stay as international as we possibly can. And we actually have a project with ANFF on a microfluidics device. And that's it. That's it from me. Now, I just said that we span 5,000 kilometers in 3 time zones. So I wanted the team to introduce themselves. So you might want to get a window open and give yourself a map of Canada. The first person to talk will be in Vancouver, and it's Siamak Grayley. Do you want to take over, Siamak, and just say who you are?
Yes, absolutely. Hi, can everybody hear me?
Loud and clear.
Yeah, great. Great to be here. Thanks for the invite. Thanks, Gordon, for the introduction. Hi, my name is Siamak Grayley. I am hailing you from our westernmost operation based in Vancouver, BC. Currently, I'm working with Canadian partners on a project to deliver access to an electron beam silicon photonics process for laser integration, as well as Gordon mentioned, cross-training, getting cross-trained on design and development project in our superconducting quantum hardware agenda, which is also a main part of CMC Quantum team. Thank you very much. I'll pass it to my other colleague.
Thank you very much. It's nice to go from Vancouver. Where are we going now, Gord?
Edmonton should be next. It's in Alberta.
Let's go to Alberta. Jessica, or who?
Susan?
Susan. We're getting a bit of a problem now. So we go to Susan from Alberta. Susan.
Whoops, sorry. You try these things.
Yeah, you know, this is the problem with the live demos. They never work live. That's why we have people like Gord and me who always receive it with a smile. We go now to Alberta, and I guess we have Susan in the room, correct?
Yes, yeah. So hi, I'm Susan Su, located in Edmonton, Alberta. So it's the capital city of Alberta. I work on silicon photonics and process design kit development for AMF and ANT technology, based on the Tanner design suite. I also create and modify code for design rule checking using the caliber verification tool. I work with my colleagues to review Calanis design submitted for fabrication on AMF multi-project wafer runs. And I also support designers using the Tanner, Caliber, and the Lucida tool. And beside the photonics work, I also support COMSOL multiphysics, which is one of the popular simulation tools that CMC makes available to Calanis. And this tool enables multi-physics design and simulation in different fields, including silicon photonics applications. So thank you very much.
Thank you very much, Susan. Do you know what? Silicon photonics and CMC and EPIC has been linked for about 15 years. You know, like 2 jobs ago, I used to work at TNO, and there we actually did a lot for an association called EPICSFAB. And there is where I meet Dan Deptak, already like, oh my God, it's been a while. I used to have more hair when I met you first time, Dan. Dan Deptak, CMC, what do you want to bring to the silicon photonics industry in Europe? Because you have been very linked in the last 2 decades with us. What do you bring? What kind of things can you bring to the silicon photonics community?
We bring all kinds of things, which I'll describe in my presentation a little bit later.
No spoilers, but I wanted you to say hello. I couldn't stand anymore.
As Gord mentioned, we're all about lowering barriers to access. So people who want to get prototypes made, we can help with that.
Can you help me introduce the next one, Jessica?
Jessica from Ottawa. Yes.
Yeah.
Let's go to Ottawa.
Okay. Yeah, I'm Jessica Zhang, and I'm in Ottawa, the capital city of Canada. So I'm actually working with various foundries, both compound semiconductors and silicon photonics, to fabricate designs for researchers and small company as well. And I'm also teaching and organizing several, actually 2 CMC offered silicon photonics courses. And actually, this course is quite unique in the world because we not only teach participant the design, but also the layout, fabrication, and testing. And through all this stage of photonics design, actually, students will learn a lot and go through this hands-on experience. And each year we can kind of create 80 that highly skilled personnel into industry and academic, and they can all hands-on and play a critical role for them. So That's
Jessica, you
my
have done a great
role.
job bringing closer by means of training, the R&D with the industry. On that, I really look up to you. It's been great. Jessica, let's go meet our next representative for CMC, Ahmed. Ahmed, where are you right now?
I'm in Ottawa. Thanks, Jose, for the invite. So my name is Ahmed. I'm a staff scientist with CMC Microsystems. So as I said, I'm based in Ottawa, working on photonic design, photonic modeling, and process design kit development. I also work with packaging services suppliers to help CMC clients with their packaging projects. These like photonic wire bonding, flip chip integration projects, very interesting projects, right? I also support our clients with CAD tools for photonics and RF modeling. And my current project is upgrading the photonics lab to help with CMC photonic design projects. So it's not just design and fabrication. We want to also improve the measurements of the tech design to tune the design. Thank you.
Thank you very much. And we go now from Ottawa to meet a person that means a lot to EPIC, Neng. Neng, thank you very much for being with us today. Tell us where you are, and most important, tell us how the rest can help you.
I'm not sure if Nung is on because I know she's traveling. Is she?
No, she hasn't arrived yet. So
she hasn't arrived yet. Okay, so yeah, I'll just briefly tell you about Nung. Nung's been working on photonic devices and circuits using silicon photonics and the silicon nitride platform from different foundries, and she's also working on the portable silicon photonics toolkit, which I'll mention in my presentation. In addition, she supports Canadian researchers who are using our photonic device simulation and layout software. So that's in a brief summary of what Nung's working on. And the next person is
Luhua.
now we're going to Montreal. Okay, so we're Luha will give us a brief intro. Are you there, Luha?
He's with us. Yes.
Yes. Hi, everyone. So I'm Luha Zhu. So I'm currently working in CMC's Montreal office. So I'm now working on the design as well as simulations of various passive and active integrated photonic devices based on silicon and the silicon nitride platform that are supported by our CMC Microsystems. So I'm also working with a Canadian foundry called Applied Nano Tools, ANT, so to provide our clients the access to the Canadian-based e-beam photonics platform.
Yes, and we have the final one before we go to the great Dan presentation, Niharika.
Hi everyone, my name is Niharika. I'm in the CMC Montreal office, and I work on silicon and silicon nitride photonic device design. I also take part in the development of the process design kit for superconducting quantum devices, and also review the layouts for CMC clients for the same. Thank you, everyone.
Thank you very much. So we met Shamak, Susan, Jessica, Ahmed, Neng was driving, Luhua, and Niharika. All of us looking forward to work closer. The way to work closer is what Dan Devtak is going to explain now. Dan, everybody is so excited with this introduction. The floor is yours.
All right, I'm going to share my presentation. Let me see if this works. All right, can you see that?
Yes, Gorilla Glass Clear.
Excellent. All right. Well, my name is Dan Devtak, and I lead the photonics team here at CMC Microsystems. And the team that you just met, we just went across the country, and we're located in several different cities all across the country. And I'm based in Kingston, Ontario, on the lovely North Shore of Lake Ontario. So I'm going to tell you a bit about CMC and the products and services that we offer to help you get access to cost-effective access to microsystems technologies, and hence the title of my presentation, Lowering Barriers to Access. So Gord mentioned our three business units, CAD, Fab, and Lab. So in the CAD business unit, we provide access to state-of-the-art software for successful design in the areas of microelectronics, MEMS, microfluidics, photonics, and embedded systems. And these are available to academic researchers and to small and medium-sized companies. So we have over 40 computer-aided design tools and design environments. We offer a secure distributed private cloud for hosting, and also related things like user guides, process design kits, application notes, training materials, and courses. So we have the CMC CAD compute cluster, which is a dedicated group of servers enabling researchers to improve the performance of large computational tasks, and also the cloud design environment, which provides researchers with secure, high-performance, remotely accessible CAD resources. And in addition, CMC is a Cadence Cloud Passport partner serving academics, which means you can get access to Cadence tools delivered via CMC Cloud. So moving on to the Fab business unit, through supplier partnerships, we offer multi-project wafer services and related fabrication services in a variety of technologies. And that means that you get simple access and reduced cost for working prototypes, because you purchase only the portion of the design space that you need, and you benefit from our, you also benefit from our expert assistance, namely my team, who you just met, to help you achieve first-time right designs. And so we also offer, in addition to multi-project wafer runs, we also offer dedicated and/or custom runs on a case-by-case basis. And CMC also delivers packaging and assembly services with related engineering support and consultation. So here are some highlights. We prototype about 300 designs per year, and about a quarter of those are photonic designs, and most of those, about 3/4 of that quarter, are silicon photonics. You can also see microelectronics continues to be an important part of our portfolio, and we also do a lot of MEMS and several other technologies. And we support multi-technology integration and co-design, for example, electronic photonic co-design. And we expect substantial increases in design numbers in all areas over the next few years. Here I list some examples of the microelectronic technologies that are available from CMC. The offerings range from leading-edge FinFET and FDSOI technologies to more mature CMOS technologies such as 0.18 micron and 0.35 micron. You'll notice several global foundries technologies in these examples. That's because CMC is a channel partner and multi-project wafer reseller for GF technologies in the Americas, and we support university and commercial clients with both multi-project wafer and dedicated runs. So this significantly broadens our microelectronics and silicon photonics portfolio. And for a full list of the technologies and their descriptions, I would invite you to follow the first link on this slide. And our fabrication schedule is available at the second link. So I'm going to talk about the silicon photonics technology from Global Foundries. So 45 CLO is the next generation silicon photonics technology and the successor to 90WG. The 45 CLO platform features monolithic integration of RF with RF transistors from the 45 RF-SOI technology, along with digital elements, silicon photonics, fiber coupling, and on-die laser attach. So the process uses advanced immersion lithography and photonic optical proximity correction, and has best-in-class performance for key parameters for things like, waveguide loss, undercut thermal phase shifter, PN junction phase shifter, input-output coupling loss, Mach-Zehnder modulator, and photodiode bandwidth. The current focus is on datacom at 1310 nanometers, but it also supports 1550 nanometers. And GF supplies an electro-optic PDK that enables co-design of both electrical and optical components, and includes a comprehensive library of silicon qualified components that can be used in your circuit design. Now I'm going to talk about AMF in Singapore, Advanced Micro Foundry. It's our workhorse silicon photonics process, and most of our clients' silicon photonic designs are fabricated in this process. It supports a standard set of features summarized here, and we supply design kits that include a library of characterized and verified standard cells from AMF. With this technology, you can make photonic integrated circuits that include modulators, detectors, stripper ridge waveguides, gratings for fiber coupling, deep trench and nanotabers for edge coupling, as well as diffraction or arrayed waveguide multiplexers and demultiplexers and filters, such as ring and disc resonators and frag gratings. And recently we added silicon nitride waveguides to this process flow, and there's quite a bit of interest in using this capability among our clients. I would add that this technology is available to European clients via CMP in France through our partnership between CMC and CMP. So CMP provides the engineering support for their European clients and then sends the clean designs to CMC for inclusion on our multi-project wafer runs. We're also working with IBM and AMF to adapt the fabrication process so that a compliant polymer connector technology developed by IBM can be used to readily couple fiber arrays to the chips with low optical loss. And so this connector technology is under development and will be available to clients sometime next year. So just sort of a quick summary of the number of photonic designs fabricated through CMC over 2 time periods. And the total number since 2007, 2008 is shown outside the box, and inside the box are the most recent 5 years. So we see a total of 950 designs since 2007, 2008, of which 690 were silicon photonics and 120 in 3.5 technologies. These designs involve both university research and companies, and a number of these designs arise from training courses that CMC runs in collaboration with universities, and which Jessica mentioned. Jessica is running these courses. So CMC collaborates with the University of British Columbia on the west coast of Canada. We've been collaborating since 2008 to deliver training courses in silicon photonics. This training is part of an initiative called SciEPIC, which stands for Silicon Electronic Photonic Integrated Circuits. And it's a program led by Professor Lucas Krastowski at the University of British Columbia. So the course begins with a workshop that includes both theory and hands-on training using the principles in the design environment. And normally we would run this as an in-person workshop, but in the last year and a half, the courses have been delivered online, and due to the pandemic, of course. So after the workshop, the students go back to their home institution and work on a design project that they have proposed. And throughout the process, they receive guidance from the instructors and engineering support from CMC. The finalized designs are sent for fabrication on a CMC brokered multi-project wafer run. And when the fabricated chips are received, they're tested by the students, and then they submit a final report to complete the course. So the test results inform the next design cycle, and either by other students in the course or as a follow-up activity by the same student. And I have to say, hundreds of people have been trained in these courses, and the results are substantive, often resulting in publications by the students or follow-up research that subsequently gets published. And some of the students have gone on to spin off companies, and companies who have participated have gone on to develop their own in-house silicon photonics expertise. We offer 2 courses every year, one in passive silicon photonics and another in active silicon photonics. And more information is, of course, available by following the link on this slide or by contacting us. So we now deliver access to an e-beam rapid prototyping technology through Applied Nanotools in Edmonton. This is the technology that Luha mentioned. Turnaround time can be as short as 3 weeks as compared to 5 or 6 months for a full flow foundry. So this is very beneficial for some kinds of research that need to be tested quickly. But the trade-off is, of course, a simpler process flow. At the moment, they can do passives with heaters. They're working on adding more features such as silicon nitride waveguides and implantation for modulators. And we are also working with A&T and another Canadian partner called Dream Photonics to deliver a process that integrates 3.5 lasers with silicon photonic chips, which is one of the projects that CMAC mentioned. Finally, I will mention this project that Nung is working on, and unfortunately, she wasn't able to join us because she's traveling today. But the idea here is to develop a prototype board that can help students to gain a thorough understanding of tests before they attempt to design their own chip. At present, we observe that new designers, they often fail to anticipate testing issues when they design their chips, and this project is our attempt to address that. So these are packaged research and education prototyping boards, and they include standard photonic blocks using CMC supported platforms from AMF and Global Foundries with both passive and active photonic devices, packaged in a cost-effective standard IC package with both DC and RF controllable circuits. The packaging is done in collaboration with the Tyndall Institute in Ireland. This can be used to learn basic optoelectronic functions and device testing. The kits will include the device designs, the design flows, and simulation scripts, so that will get you started on your own designs, and it'll allow you to learn some of the more challenging aspects of photonic design before investing in chip fabrication. So that's it for me. I'd be happy to take questions. Thank you very much for your attention.
Thank you very much, Dan. It's so great to hear from you. But most important, I want the 750 members to help you. So this is the epic question. What can you do for them, and what can they do for you?
So you're asking me what can I do for them? Well, we can provide access to CAD. We can get their prototypes fabricated. We can also help them with testing. So I think that's sort of the 3-line version of it.
I want to, when it comes to testing, this is one of the big challenges that we have actually identified at Epic. We can do packaging, and you are quite strong at this, and we have seen a very strong supply chain. But when it comes to testing, we had in the beginning the presentation from NRC, and they do all the wafer level manufacturing. Is there anything going on wafer level testing? And is CMC could help us solving this big challenge for big production?
Right. So we don't have a good solution for wafer level testing at the moment, but we are working with a company in Quebec City that's a spin-off of Laval University called EVA, EHVA. They do wafer level testing. So we're trying to figure out the best way to get to make use of wafer level testing. We're aware that it's a hot and important topic.
Dan, not you, nor the world. The world doesn't have a solution for the wafer level testing of active components yet, apart from VCSELs, of course, but for active photonic integrated circuits, we don't have a solution. But Dan, my flight is leaving very soon. I need to go to the airport. Madison, would you be kind enough to take me to the airport?
I would be glad to, Jose. You might have to wait for me until I come and meet you, though, to pick you up.
Yes, well, we are all going to meet at Photonics West in San Francisco. I can't wait. I'm going to go there. I don't care how many PCR tests I need to pass, and how many masks I have to wear, and how many people are going to tell me, are you crazy? We're not traveling, it's pandemic. I'm going to go there because I can't wait anymore. It's been 2 years. And with online, we did as good as we could to keep us close, but nothing will solve that we get together again. Madison, thank you very much for arranging this. OPTONIQUE is a fantastic local cluster, and we're a family. Thank you for bringing me closer to my Canadian family.
Thank you so much, Jose, and thank you to your whole team for bringing us closer to all of your 750 members of EPIC. It was really a pleasure to be here with you all today.
Until the next time, all of you, take care of each other. Enjoy a great glass or a nice beer. It's the evening here. It's already 7 o'clock somewhere in the world. So let's have a beer all together until the next time. See you later. Bye-bye.
Thank you all.
Bye, everyone. Thank you so much.